pressure at point C is equal to get pressure F over F is equal to 25 Newton and A is pi time the diameter is 0.3 square over pi d square over 4 ini pi d square over 4 okay. Okay, so you get the pressure at point C. Is it okay if I didn't calculate it? I mean, I just left it, the equation, and then how the equation is about, and then I just left you to calculate what was the number. Okay, so you get PC here. Okay, and then to get PE, you know that the pressure varies with okay, and then PE is below point C. So PE is equal to PC plus OGH. So PC, okay, whatever you got here, plus the density of the water is 1000. G is 9.81 and H is 0.25. Okay, so you got here PE. Okay, you need to calculate by yourself. And then next question is to get the pressure at point D. Okay, you got here is pressure at point E. But the question is calculate the gauge pressure at chamber A and chamber B. So what is the pressure at chamber A? Okay, in my note, I told you that if the working fluid is air, you can ignore the pressure varies with the H. So we can assume that in this chamber, okay, in this whole chamber A, the pressure is same with point E. Okay, so pressure at point A is PE. Okay, pressure at chamber B, okay, is equal to PD, where PD is equal to PC, and then point D is above point C. Okay, when it is above point C, the pressure is lower than point C, or negative sign in front, OGH. Okay, pressure C, whatever number you got here, minus density of air is 1000, G is 9.81, and H is 0.25. Okay, and you get PD. Is it okay for the first question? We go to question number 2. Okay, I assume you has make a screenshot on your device. Okay, I will erase it. Okay, we go to question 1B. Okay, 2 parameter used to measure H of building. If the barometric reading at the top and bottom of the building is 730 and 755 millimeter, determine the H of the building. Assume the air density is 1.18 kilogram per meter cube and mercury density is 13,600 kilogram per meter cube. Okay, there is a building, and then at the top is the pressure is 730 Hg, and at the bottom P equal to 755 Hg. Okay, this is the data given. Okay, only 2 point. Okay, and then the density of air is 1.18 and density of Hg is 13,600. Okay, based on these two information, we can determine that P at the top of the building. Okay, P at the top of the building using the H of the was it Hg mercury. Just use OG hash where O is O for the mercury, 13,600, G is 9.81, and hash is 0.73. Sorry. Okay, this is in millimeter, so you need to change it into SI. So you got here P top, okay, and the unit is Pascal. And then one more is you need to get the at the bottom equal to OGH again, and density is 13,600, G is 9.81, and hash is 0.755. So you got the pressure at the bottom of the building. Okay, now you know that the pressure at the top and the bottom, okay, why there is a pressure difference? Because there is different H, and the working fluid in this area is air, which have this density of 1.18 kilogram per meter cube. Okay, the density is too low. So if it is the location is just in a room, we can assume that there is no pressure difference. But as the building is too high, there will be a pressure difference added from the top and the bottom of the building. So the pressure difference is due to OGH. Okay, so P top minus P bottom, okay, sorry, is equal to the density of air 1.18, G is 9.81, and hash is the hash of the building. Okay, using this equation, you already got the P top and P bottom of the building. So using this equation, you can determine the hash of the building in meter. You can make sure if you use the equation OG hash, the unit is Pascal. Settle for the second question. Any question? Too easy in it. Even the final exam is too easy. I don't think you should study more for fluid mechanics. Okay, any question? I hope I didn't say learn.
Sir,
Boleh.
Yes. Any question?
untuk
No.
kalau chapter tu dah masuk dalam midterm, dia masuk lagi tak dalam final?
Tak perasan. Normally the topic that has covered in midterm will not be covered in final. But I need to check again. I'm not aware about it.
Okay, sir. Thank you.
Okay. So there is no question about manometer in midterm in it. Okay. Okay. This time you need to check about the manometer. Okay. Question C. Okay, a cylindrical has diameter of 150 millimeter. Okay, this question. Okay, the diameter is 450 millimeter, and then the length is 740 millimeter. And the cylinder is floating on the kerosene with its long axis vertical as shown in figure Q1C. 150 millimeter of the H is above the surface. Okay, this is 150 and the below is 600 millimeter. Determine the density of the cylinder. Okay, for this topic, for buoyancy, you know that the wedge of, uh, Okay, what you need to do first, if you are solving the question in the buoyancy, is to first is you need to have the free body diagram. Okay, free body diagram. So from here, you know that if I change the cylinder into 1 point, okay, there is only two force, okay, acting on the cylinder. First, it is wedge, and second is the buoyancy force, FB. Okay, there is no other force acting on the cylinder. And you already know the wedge is equal the, okay, sorry. From this free body diagram, you know that the wedge is equal to the buoyancy force. Okay, so the wedge of the build of this cylinder, okay, wedge is equal to O times V times G. And for the buoyancy force, it's also OVG, but this is for the water displaced ataupun displaced from the uh, from this. Okay, this is from the object, and the other for FB is a OVG of the water displaced. So for this part, okay, the density is the one that you are searching. The volume of the cylinder is equal to area, okay, the area of the bottom. So the area of the bottom is pi times 0.45 square over 4 times the h. Okay, the h is 0.75. Okay, rho v, and g is 9.81. Okay, equal to, okay, the next is the density of the gaussian is 800, and then v is equal to pi 0.45 square over 4 times 0.6. Okay, the only volume, okay, underwater is only 300 millimeter, and then G is 9.81. Okay, so from this question, okay, you can see that sorry, this is for, sorry, my handwriting. Okay, so you can eliminate the value that is same at the left and the right of the equation. So G is the same, and then the area is also same. So what is left is 4 times 0.75 is equal to 800 times 0.6. So from this equation, you can determine the density of the object. Okay, settle first part of the third question. Okay, I will erase the first part. Okay, we'll go to the second part. Okay, if the cylinder is placed in the fresh water, rho equal to 1000 kilogram per meter cube, determine how much of its weight would be above the surface. So the situation is still same. If it is the situation of, okay, the situation is still same. It is the situation where the weight is equal to FB. Okay, there is no other force acting. Okay, just change from Gaussian into the water. And then W is equal to OVG again, equal to OVG. But this one is for water, and this one is for the object. Okay, OVG, you already get density now. And then V equal to A times H, okay, for the cylinder. And then G, okay, equal to the density of the water is 1000, and then A time H for the volume, and G, okay, gravity. Okay, you can cancel several part here because you have the same at the left and the right. Okay, G cancel with G, A cancel with A. So what left is just the row and the hash. Okay, row of the object you already get from previous question. The hash of the object is 0.75 equal to 1000 times hash. So density you have calculated before. So you can get what is the H. How much is H would be above the water. This H is under the water. Okay. So H above water is equal to 0.75 minus H that you get here. Okay. Unit is in meter, then the problem is settled. Okay, this goes your first 10 marks. If you do your exam in previous year. Okay, any questions so far? Okay, I think no question. Okay, we go to question B. Question two. Okay, question two. It's too easy in it, Azim. Okay, question 2A. Air whose density is 1.3 kilogram per meter cube enter the duct of an air conditioning system at a volume flow rate of 12.7 meter cube per minute. If the diameter of the ducting is 40 centimeter, determine the velocity of the air at the duct inlet in meter per second, and second, the mass flow rate of air in kilogram per second. So still an easy question. Okay, the density. Sorry. Okay, density is 1.3 kilogram per meter cube, and then the V dot. Okay, volume flow rate is 12.7 meter cube per minute. So, okay, you need to change it into meter cube per second. So what we can do is 12.7. Okay, you know that this is per minute, and then okay, meter cube per minute, and you know that 1 minute is equal to 60 seconds. So for this one is the flow rate is 12.7 divided by 60 is equal to 0.212 meter cube per second. Okay, for the first question, determine the V. Okay, V dot is equal to VA. So V is equal to V dot over A. So V dot is 0.212, and the area of the ducting is, the diameter is 40 centimeter. So the area is pi time, okay, 40 centimeter equal to 0.4 meter square over 4. So you can get the velocity of the air. Okay, second question, the mass flow rate of the air in kilogram per second. So you know that m dot is equal to v dot times density. Okay, the density is 1.3. Okay, and the flow rate is 0.212. Okay, here you get a m dot in kilogram per second. Okay, another question, Settle. Okay, go to question 2b. A pressure tank of water has 10 centimeter diameter orifice at the bottom, where water is charged to the atmosphere. The water level is 2.5 meter above the outlet. Okay, the tank air pressure above the water level is 250 kilopascal absolute, where the atmospheric pressure is 100 kilopascal. Neglecting friction effect, determine the initial discharge rate of the water from the tank. Okay, the question is, there is a tank, there is a tank, okay, there is a tank, and there is a orifice at the bottom, okay, and then this is, okay, this is where the water go, okay, this is the edge of the water, and the pressure at the above is equal to 250 kilopascal, and this is absolute. Okay, so it's not it is a closed tank. Okay, this one is open to the atmosphere, where the P atmosphere is equal to 100 kilopascal. Okay, so how to solve this question? What the question one is the initial discharge of rate of the water. Okay, so as this is a fluid in the dynamic, so what you can do is using the Bernoulli equation, P equal over OG plus V square over 2G plus Z is equal to P over OG plus V square over 2G plus Z. Okay, and then, okay, you know that the H of the water is equal to 2.5 meter, and then, okay, it's a tank, okay, when okay, 250 kilopascal, it is in the absolute, okay, and at the whole, the P is P atmosphere, the H is 2.5 meter, and then V for the velocity, you know that this is a tank, while for the second point, it is a hole at the. So first, when using the Bernoulli equation, you need to determine where is point 1 and where is point 2. So I want to set now, point 1 is above the water level and point 2 is at the orifice where the water flowing out. Okay, so at point 1, is there any pressure at point 1? Can anybody answer? Can I cancel P, or there is a pressure at point 1?
Point 1.
Is there any pressure? Can we ignore the pressure or not?
Yeah. Point 1.
You want to ignore the pressure. Okay. So the situation where we can ignore the pressure is when the pressure is equal to P atmosphere. Okay, you can differentiate between point 1 and point 2. Point 1, the pressure is 250 kilopascal, and this is absolute pressure, where the P ATM is 100 kilopascal. So at point 1, the P is equal to 150 kilopascal if it is the P gauge. Okay, you need to take if you want to cancel it, it is at the point where P gauge is equal to 0. So at point 1, P is equal to 150 kilopascal P gauge. You cannot cancel P. Okay, so next, go to V. Okay, for V, for the velocity, okay, I hope you can understand in which case you can cancel P. You can cancel P at point 2 because the pressure at point 2 is P ATM. Okay, so you can cancel P2, but not P1 because the pressure is 150 kilopascal. Okay, now we go to the velocity. Okay, velocity at point 1. Okay, it is a tank where you can assume now the velocity is too low because the tank is too large. Okay, so cancel for V1. But at point 2, the velocity is not, the area is not too large because you already know that the orifice is 10 centimeter. So where's the question? The orifice is 10 centimeter. Okay, you already know the area. So the velocity is not 0. Okay, next is about the Z. Okay, Z as point 1 is 2.5 meter above point 2. So you can cancel Z1, but you can cancel Z2. The value for Z2 is 0. So for this part, okay, P is equal to 150 kilopascal. Okay, 150 kilo. Make sure that every time you use any equation, the unit that you use is in SI. So for kilopascal, you need to change it into 1000. Okay, density is, what is it? Water. So water density is 1000 and G is 9.81. Okay, plus Z1. Z1 is 2.5 meter equal to zero point 0.2 velocity over 2G plus, sorry, this is in equation. Okay, this is V2. So from this equation, you can determine V2 in unit meter per second because this is just one question with one unknown. So you can easily get V2 here. And then to get the discharge rate, okay, discharge rate is V dot. V dot is equal to V2 times A, the area. So the V2, okay, whatever you got here, time A is pi d square over 4. Okay, by calculating it, you got the final answer. Okay, thank you. Still too easy, I think. Everybody can get full mark until now. Don't worry. For this year, this question still easy. Okay, now question. Again, we go to question 2C. Okay, water enters a hydraulic turbine to a 30 centimeter diameter pipe. Okay, at a rate of 0.6 meter cube per second and exit through a 25 centimeter diameter pipe. The pressure drop at the turbine is measured by a mercury thermometer to be 1.2 meter. Okay, the pressure difference is 1.2 meter. For a combined turbine generator efficiency of 83%, determine the net electric power output. Disregard the effect of kinetic energy coercion factor. Okay, it is given the V dot. Okay, the flow rate is 0.6 meter cube per second. Then you know that V at point 1. Okay, V at point 1, okay, enter the turbine, is equal to V dot over A. Okay, we can calculate it and get what is V dot over A. Well, you can either use the area is pi d square over 4 or pi r square. It's up to you. I prefer to use pi d square over 4. Okay, there is no advantage, no disadvantage to use pi d square over 4 or pi r square. It's up to you which equation that you think is much easier for you to use. Okay, V1 is equal to V dot over A, and you also can determine V2. V2 is equal to V dot over A at point 2. Okay, the difference is this one is A is using the diameter 25 centimeter. For this point, A is using the 30 centimeter. Okay, you can determine V1 and also V2. And then the second is, you know the pressure difference, okay, delta P, or delta P is equal to a pressure drop. Mean if it is pressure drop, so it is P2 minus P1. Okay, 0.2 minus 0.1 is equal to 1.2 meter Hg, or rho GH, where rho density is 13,600, G is 9.81, and H is 1.2. Okay, now you got the pressure difference in Pascal. Okay, then you can directly using the power equation. So for the power equation, it is P over rho G plus V1 square over 2G plus Z plus H for pump equal to P over rho G plus V square over 2G plus Z plus H turbine plus H loss. Okay, from this equation, there is no pump and there is no head loss. Is there any head loss? No head loss. Okay, there is no head loss, and there is there any Z? Okay, there he didn't give the value for Z, so we can assume Z is too small. Okay, so this is just the equation now. P, V, and P2. Okay, this is P1 and this is P2. So, okay, V1 and V2, V1 and V2, you already know the answer. But P1 and P2, you didn't know specific what is P1, what is P2, but you know that P2 minus P1. So the equation now is equal to V1 square over 2G minus that V2 square over 2G equal to P2 minus P1 over rho G plus H turbine. So now you get the H turbine. After you get the value for H turbine, okay, what you can do further is you can calculate the power generated by the turbine. The power generated by the turbine is O G V dot H T. Okay, O G V dot H T. V dot, you know, density, you already got the density, you know the gravity, V dot, and the HT you have calculated before. So you can get the power of the turbine in watt. But in this question, it said that for a combined turbine generated efficiency is 83%. So the efficiency is equal to the power, okay, the electric output, electric over P mechanical. Okay, this is the P mechanical. Then from this equation, okay, you already know the efficiency. Efficiency is 0.83 equal to P electric, okay, the one that you are searching, over the P mechanical, okay, the amount that you calculate here. So you can get the P electric. Okay, second, another 25 marks. Any question? How many of you are left here? 39%. Okay, no question. So far, still okay? Oops. Stop video, share. Okay, so far. Okay, let's go to the third question. Okay, the third question, the solution is to is it longer than before. Okay, should we solve it or you want to try to solve it by yourself? Okay, let's try to solve it. But the solution is is a bit long. Okay. Yeah, I need the whole screen. Make sure my paper is big enough. So this question, okay, water at 15 degrees C, okay, the density is 1000 kilogram per meter cube, is to be discharged from a reservoir at the rate of 18 liter per second. So you know that, okay, V dot is equal to 18 liter per second. So for SI, it is meter cube per second. So how much is it in 18 liter per second to meter cube per second? 1 meter cube equal to how many liter?
0.001.
Okay, yes. 1 liter is equal to 0.001 meter cube, or 1 meter cube is equal to 1000 liter. So 18 liter per second is equal to 0.018 meter cube per second. So what if you don't know what is 18 liter per second in meter cube per second? How you are going to do? Using Google. Okay, simply just meter cube to liter. Then you get that 1 meter cube equal to 1000 liter. Or if you want your life is to be easier, if the question is now is 18 liter per second, 18 liter per second to meter cube per second. Okay, 0.0018. So, okay, I don't want to hide Google from you all because I know that everybody will try to use Google in solving my question. To horizontal cast iron connect in series and pump figure Q4. The first pipe is 20 meter long and 6 centimeter diameter, while the second pipe is 35 meter long and has 4 centimeter diameter. So from this two information is you can determine what is V1 and V2. Okay, let's start with pipe 1. Pipe 1. Okay, L is equal to 20 meter and the diameter is 6 centimeter. 0.06 meter. So you can determine the V. V equal to V dot over A equal to 0.018 over A is pi 0.06 square over 4. Okay, you get the number here. I think for this question we need to calculate. Okay, 0.018 over pi is pi times 0.06 square over 4. Okay, it is 28.3 meter per second. Can anybody please try to check back my calculation? Is my calculation for the V is correct? Okay, now you get the value for V. Why the value for V is important here? Because you need to for this question, okay, what you need to know is what is it? The total head loss. To determine the total head loss, you need to know the type of fluid. Either it is what is it? Laminar, transition, or turbulent. To know the type of fluid, you need the Reynolds number. So Reynolds number is equal to I didn't give the dynamic viscosity. Rho V D over mu. Okay, so rho is 1000, V is 28.3, and the diameter is 0.06, and the mu is what is mu for water? 3.3 Celsius for this for the velocity. Okay, am I doing wrong? Oh, okay, so I'm doing wrong. So what is the answer? 6 point?
6.366.
Okay, rho VD over mu. Okay, so as I told you before, okay, what you need to do is dynamic viscosity of water. Okay, 8.9 times at 8.9 times 10 power of -4. Okay, one more solution is just go to my slide. Okay, my slide, what is it? Fluid. I didn't say fluid now. BMMH, I didn't. Relational, okay, relational, go to internal flow. water at 5 degrees C. Okay, okay. I think this one is okay. So just take mu is 1.5 times 10 power of negative 3. (1.5 times 10 power of negative 3). Therefore, your examination, okay, in case I didn't give the value for anything, mu or anything, you just write the value of mu and then you just state the sources here. Either the sources is internet or anything. Because it is an open examination, you can refer to any source to get the value for mu or anything. So for the unit number, okay, you can calculate here OVD over mu, and then you will get the value for the unit number. Okay, can anybody please calculate for me what is the unit number here? Oh, V is 6.3. 6.367. Okay, has anybody get the value of unit number? And 254,000. Okay, 254,000 something. Okay, and I just there it is. Okay, so unit number is 254,000, and you know this is a turbulent case. Okay, when it is in turbulent, what you need to refer is the what is the diagram name? Where's the slide? Okay, this one. Okay, the Moody chart. So you already know the unit number. The second thing you need to know is the relative pipe roughness. So relative pipe roughness is equal to the type of the pipe over D. So go back to the question. Okay, to get that cast iron pipe. Okay, it is in cast iron. So go back to your slide to see that what happens if it is cast iron. So where is it? Where is it? Where's the information for cast iron? Okay. Okay. For cast iron, okay, the roughness is 0.26. So for this question, the roughness is 0.26. Okay, refer to this table. Yeah, 0.26. And then you also know the diameter. Okay, diameter is 0.6. So now epsilon over D is equal to 0.26 over 0.0, sorry, 0.26 is in, what is it, millimeter. So you need to change the diameter to millimeter now. So it's not 0.06, but okay, when it is referred to diameter, 6 centimeter is equal to 60 millimeter. 60 millimeter. So the answer is what is 0.26 over 60 is 0.004. Okay. So the number is important now is 254,000 and eta over d of 0.004. Okay, please remember these two numbers. 254,000 is 2.5 times e power 2.5 power 10 power 5, and the second important is 0.004. So go to the Moody diagram. Okay, from this Moody diagram, okay, make it bigger. Okay. And then go to find the option of pen. Okay, you know that the important information is 2.5 power of 10 power of 5. Okay, 10. So where is it? Okay, so 2.5 is about this number. Sorry, it's hard to write to make a statement here. Okay, and then the second important is 0.004. Okay, for this line. Okay, check where is the intersection for these two lines. Okay, it's about here. Okay, so for these two lines, the intersection is f equal to 0.029. Okay, I think it should be about here, 0.029. With these two information, you now get f. F equal to 0.0, like 0.029. Okay, 0.029. Is it okay up until now? So you know that now we got the f, okay, and then if you remember from the last slide, okay, you can determine the value for the losses. Okay, the equation for the losses is what is it? The equation for losses. Okay, this one is the equation for losses. So losses is total f L over D V square over 2G plus the minus losses V square over 2G. Now you get the F. Okay, you know the L, you know the D, you know the velocity, but you haven't know the minor losses. So go back to the question. Okay, for this question, okay, the minor losses for the first pipe is only the entrance. Okay, the pipe entrance is sharp edge. This is the important information you need for the minor losses. The pipe entrance is sharp edge. So when the pipe entrance is sharp edge, okay, go back to the slide. Okay, and then find for the minor losses. Okay, the minor losses for sharp edge inlet. Okay, the KL is equal to 0.5. Okay, sharp edge entrance, KL is equal to 0.5. Okay, finish for the slide. Okay, now F equal to 0.039 and KL is equal to 0.5. Okay, there's only one minor losses in this question. So using the equation for HL, for the first part only, HL is equal to, I forget the equation already. Okay, head loss for the first pipe is F L over D plus sum of K V square over 2G. So F is equal to 0.029, L is 20 meter over D. D is 0.06 plus sum of K is only 0.5, sorry, 0.5 V square over 2G. V is, how much is V just now? 6.36. 6.37 square over 29.81. Now you get the losses for the first part in meter. Okay, that is for first part. Now you need to rewrite again to get the losses for the second part. Okay, part 2. So just write for the second one is pipe 2. Okay, pipe 2 L is equal to how much L for the second pipe? 35 meter. And the diameter is 0.04 meter. Okay, we do again everything. V equal to V dot over A equal to 0.018 over A by 0.04 square over 4. Okay, you get here the V dot V for the second part. And then calculate again the Reynolds number. V equal to OVD over mu. You get the Reynolds number for the second part. And then just do the same, okay? Because I know you get the Reynolds number, and then you also need the relative roughness 0.26 over 40. Okay, you got the number here, and then you got the F for the second part. You also need the KL for the second part. So for the KL, okay, for the second part, okay, losses associated with the connection of the pipe are negligible. So you can ignore the losses due to pump. And then the second losses here for the second part is only at the exit. So refer to my slide again. Go to form pipe exit. This one is for the entrance. This one for the certain gateway expansion, minor losses, sudden gateway expansion, elbow, okay, elbow, and then minor losses for pipetting, and loss efficiency for inlet and for exit. Okay, for pipe exit, is there any pipe exit? So for pipe exit, okay, pipe exit, okay, you can use a sharp edge, okay. This one for exit. So KL is equal to alpha. Where is pipe exit? This it should be another for pipe exit. This one. For pipe exit, okay, K equal to 1. Okay. So this is KL4 but is it is K equal to 1. And then okay, for the hash L for the second pipe, okay, again hash L is equal to FL over D plus sum of K V square over 2G. Okay, and then put all the information. You got the hash L for the second pipe. And then for the determine the total pipe, okay, hash L total is equal to hash L for the first pipe plus hash L for the second pipe. You get the hash L total. Okay, so for 17 marks for the second question. Okay, any question for this part? Susan Solani. It's not so difficult, but it's just a long question. So for this semester, there is also a question, not same, okay, but like this question. I mean, it's just a long solution. Okay, actually, not so many people, person who answered this question last semester, but fortunately, everybody that answered this question got the full mark for this question. Okay, it's now 12:30. Okay, I think for question 4 and question 5, we spend it for the next week. Is it okay? Or you still got power to continue? So okay to continue or okay to continue? Okay to continue now or okay to continue next week? Next week, okay. Okay, so that's all for today. Okay, the question has 7. Okay. I will put for the assignment. Bila test. Okay, test is I think it's on 10th of July, if I'm not mistaken. 10th of July evening to quarter past 2. Lab test. Oh, okay, lab test. Okay, lab test will be next week. But for next week, okay, it will be in the night time because BMMA, BMMH, and BEA will take the lab test in the same time. So next week, what time you still free? Or every night you are free? Monday to Friday. What time you're free? Thursday. Only Thursday night you have something else? Or only Thursday night you are free? So only Thursday night and Friday night you got something else. Is that correct? Or you are free on Thursday and Friday night? Free on both day. So on Friday and on Thursday and Friday you are still free. So you are not free in Monday, Tuesday, and Wednesday. Is that correct? Okay. Okay, I will let the other courses know, and then I will let you know for with WhatsApp about your about the lab test. Okay. Okay. Thank you.
Thank you, sir.
Okay. Thank you.
Okay, thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir. Assalamualaikum.